Let's analyze the decay of the S quark. First, the S quark as an ordered pair is represented by the S value equals 2 divided by 2 and the T value equals -1. And the composition is, in terms of ordered pairs, is a -1/2 for the S value and a (2) for the T value, which you can see over here represents a generic U quark with a V, a T, and T rishons. In addition, since the generic U cannot represent the S quark, we actually have a scalar boson minus, which is composed with a anti-V flavored rishon and a anti-T rishon. Now let's look at these graphically. Graphically, we have the generic U, which you can see is composed of the T, and the V. We have the boson minus, which has the flavored anti-V and the anti-T. In addition, there's an associated particle-antiparticle pair of prime T and anti-T rishons. And of course, the anti-S particle will be composed of corresponding particles with the opposite quanta. So now, let's see if the S quark emits a boson W minus, which as an ordered pair is S equals 5/2, -3, then that will leave a U quark. The U quark is designated -3/2 for the S component, (2) for the T component. And we can see here that the U quark will be composed of a generic U and a neutral boson, which will include a T prime and anti-T rishon. And here we can see that the W minus boson that is emitted will be composed of a scalar boson minus that is composed of an anti-T flavored rishon and anti-T rishon. In addition, it will include, as does the U quark, but the opposite designations, a anti-T prime and a T rishon. For more clarity, let's look at these graphically. So let's look at the W minus, which will include the original scalar boson minus that was included in the composition of the S quark, which has the anti-V flavored and the anti-T prime. And additionally, it will include an anti-T prime and a T Rishon. But also, we can see there's been an exchange of two of the Rishons, the red Rishon that was yellow with red feature for a blue with a red feature, which will give us a T Rishon pair anti-pair, which will carry away the -1/2 spin and join it to the W- particle. Now, let's look at the U quark. The U quark is now composed with a generic U that was composing the S before, and a neutral boson composed with a prime T Rishon and an anti-T Rishon. As we can see, this is the first time we've seen a composition that doesn't have a flavored particle. The U quark does not carry a flavor component or have flavor quanta. And if we look closely at W-, we can see that when it combines with the anti-S, this scalar boson minus will annihilate with this scalar boson plus, and it will leave the generic anti-U combining with the boson 0, and therefore with this boson 0 form an anti-U quark. The particle-antiparticle boson 0 will not make any contribution to the quanta of the particle. Let's take another look at the ordered pair designation and components of the U quark. So we can see that the designation for the U quark is S equals -3 divided by 2, and for a T, 2. And for the generic U component of that U quark, we have S equals -1 divided by 2, and for T equals 2, which we can see here in this assembly of the V and T Rishon groups. And we also have a neutral boson, which we can see is designated here as -2 divided by 2 for S, and T equals 0, with the composition that we have shown earlier of a T prime and a anti-T Rishon. And so there's the analysis. The decay of the S quark by emitting a W-. And so next we will take a look at the quanta associated with the S quark and its decay products.